So today we're going to go over notes for section 8.3, which is trigonometric identities. Our objective is going to be to use algebra to simplify trigonometric expressions and establish identities. This first thing I just want to read over to you, you don't need to write down. It says two functions f and g are said to be identically equal if f of x equals g of x, for every value of x for which both functions are defined. I think you guys probably understand what identically equal means, but the part that really want to stand out to you is it says for every value of x. So keep that in mind as we head into some examples in a second. Such an equation is referred to as an identity. An equation that is not an identity is called a conditional equation. So here's some examples of identities. These are going to be equations that are always true no matter which value of x you substitute in. So you'll notice that this is a perfect square trinomial in its factored and multiplied out form. This is an identity we've learned before for sine squared plus cosine squared, and this is a reciprocal identity we've also seen before. These would be true for any value you might substitute in for x. Some additional examples I wanted to show you are examples of conditional equations. These are equations that are only true for specific values, and the fonts or the type's a little bit hard for you guys to see, but if you think about the equation 2x plus 5 equals 0, it's only true when x is negative 5 over 2. Every value of x would not make that true. The same for sine of x and for sine equaling cosine. You're only going to see very specific values that make those true. The next thing I want you guys to do is take a minute in your notes to copy down some identities. Now, all of these identities are ones that we have seen before. And let me just go over the equal signs in a few spots because they don't look real obvious. This should look like an equal. All right, so take a minute to copy these down. None of these identities are new. We have these in our notes from previous sections. So these should all look familiar. I just want you to have them in your notes for this section because we're going to use them quite a bit, and I want them to be readily available to you as we go through notes and through your homework assignment related to this section. So now would be a good time to maybe pause the video and go ahead and copy these down into your notes. And when you're ready, hit play, and I will go ahead and move on to the first example. All right, so example 1. All throughout example 1, you're going to get really specific directions as to how to simplify and how to work with the identities, but the majority of your homework will not give you this kind of added directions. So you're going to want to just pay attention to the different techniques that we're using as we go through example 1, because these would be the same techniques that you'll have to keep in mind and decide to use on your own when we get to example 2. So first example, it says to simplify cotangent of theta over cosecant of theta by rewriting each trigonometric function in terms of sine and cosine functions. So let me rewrite cotangent of theta over cosecant of theta, and using some properties, cotangent of theta, if you look at your quotient identities, is cosine of theta over sine of theta. And cosecant, if you look at your reciprocal identities, is 1 over sine of theta. So whenever we have a fraction over a fraction, we're going to use multiply by the reciprocal. So if I rewrite that, cosine theta over sine theta, you'll see some simplifying or reducing that we can do as we multiply. Diagonally, we can reduce sine of theta and sine of theta. So multiplied together across the top, I just have cosine of theta over 1, which would just be cosine of theta. So the whole point of showing you that is, again, just to show you that one option for simplifying these expressions is using quotient or reciprocal identities to rewrite kind of these functions that don't have anything in common to have something in common that we're able to reduce. So there's part A. Example 1, part B, tells us to show that cosine theta over 1 plus sine theta equals 1 minus sine theta over cosine theta. And we're given specific instructions to do this by multiplying the numerator and denominator by 1 minus sine theta. So I'm going to take the left side of the equation, rewrite it on my paper, and I'm going to show that this is actually equivalent by taking the left side and multiplying numerator and denominator by 1 minus sine theta. And I'm going to put some parentheses in just to make sure it's really clear what's happening. The goal when you see something like show is almost like a proof. You're trying to actually show the work in between the steps from getting from the left side of the equation to showing that it is in fact equivalent to the right side. So if I work through this, I'm going to go ahead and leave the numerator pretty much like you see it. Just write the two terms side by side, two factors I should say. In the denominator, I'm going to go ahead and distribute, which you guys probably are more comfortable calling FOIL, but it's distributive property. 1 minus sine theta plus. Notice in the denominator, I have a minus sine theta and a plus sine theta. Those together would make 0. And then if you notice in our denominator, we now have a sine squared. So I should automatically be thinking about any way that I might be able to use a Pythagorean identity. And just as a reminder, the Pythagorean identity that has a sine squared looks like sine squared theta plus cosine squared theta equals 1. Now that's not exactly what I have, but I could manipulate the identity a little bit by subtracting sine squared from both sides. And I'll get that cosine squared theta equals 1 minus sine squared theta. And you'll notice that now these two match. So I can use substitution and just kind of think of this as kind of like some side work to say that this is now equal to the cosine of 1 minus sine theta over cosine squared theta. Now my goal at the beginning was to show that this fraction equals this one. So you'll notice I'm getting close. I need to get rid of this cosine in the numerator and one of the cosines in the denominator. And because they are factors connected through multiplication, I can go ahead and reduce one cosine from each. So this would be 1 minus sine of theta over cosine of theta. And that's what I wanted to show. I like to put a check mark or a happy face because it makes me feel like I finished the question. But really all that we were trying to do in this problem was show the work in between the left side to the right side of the equation. All right, moving on to example 1, part C. We're told to simplify the addition of these two expressions by rewriting the expression over a common denominator. So when you have two denominators that are not the same and they don't share any common factors, usually we multiply them together to create our common denominator. So I'm going to write down here what each piece would look like with the common denominator. It would be sine u, cosine u. If I wanted this denominator to now match my new common denominator, it would need a cosine. So I would need to multiply that into my numerator as well. The second fraction has the cosine, but it needs the sine. So I'm going to go ahead and multiply what's already there in my numerator by sine. Now that my denominators match, I can go ahead and write this as one fraction or one term and do some maybe distributive property in my numerator. This would be cosine u plus sine u cosine u plus cotangent u sine u minus, and I'm just going to be thoughtful here, noticing I'm multiplying a cosine times a sine. That's the same as what I have here. I'm just going to write it in the same order, since multiplication order is something you can switch back and forth. It doesn't matter. So now looking at this fraction, hopefully you see these two terms. They're the same, but one's positive and negative. So if I were to add those two together, it would become 0. So I'm left with cosine of u plus cotangent u sine u over sine u cosine u. So again, nothing I can really maybe more simplify, except just thinking towards something that might share a common term or a common factor. I notice here cotangent I know has a piece or is related to sine. So I'm going to rewrite this a little bit as cosine of u plus cotangent, using my quotient identities, is cosine over sine So you're going to have to be careful on questions like this, that you really try to simplify as far as you possibly can. Here I would be able to reduce the signs. I'll be left in my numerator with cosine u plus cosine u all over sine u cosine u. Well, what is one cosine plus another? It would be equal to 2 cosine u over sine u cosine u. And hopefully you'll see here now I can reduce by 1 cosine. And my final answer to this is 2 over sine of u. So kind of started out looking a lot more complicated than that, but you're able to simplify it all the way down to that. So that's example 1, part C. Okay, last piece of example 1, part D, suggests that we use a technique of factoring. So something that you have to get the hang of looking for is how we could factor using these trig functions. What I want you to see here with sine squared v minus 1 is that it actually has the same relationship as the difference of two squares. So I'm going to rewrite it as sine v minus 1 times sine v plus 1. And then in your denominator, hopefully you see that both terms have a tangent, so I can factor that out. And now you see a factor of sine v minus 1 in the numerator and denominator, so I'm able to simplify by that. And I'm left with sine v plus 1 over tangent v. And since sine and tangent, well, they do share some things, like tangent is made up of sine over cosine. Because sine is connected to the 1 through addition, you're not going to be able to reduce those anyways. So I'm going to go ahead and say that this is the simplified form, or as far as I can get. And that would be example 1, part D. So really, guys, the point of example 1 is to show you some different techniques that are going to be helpful in approaching problems in example 2. So things like rewriting a function using sine and cosine, multiplying a numerator by a denominator, rewriting an expression over a common denominator, and things like factoring. So keep all those things in mind as we head into example 2. And just kind of as a warning, the hardest thing about these questions is going to be that I can't tell you, always do a question like this with these 5 steps. It's going to have to be, you look at the question, you decide, how could I rewrite one of the functions, or what identity do I recognize? And using that to help you manipulate, to simplify, to substitute, and then seeing if you can actually get towards your goal. So what we're doing with an identity is trying to take either the left side of the equation and show that it does actually look like the right side, or take the right side and make it look like the left. The easiest thing to do is usually to start with the more complicated piece and make it look like the more simplified piece, because it's easier to kind of break things down and cross out and simplify than it is to maybe take something and make it look more complicated than it is. Usually I take the left side because my brain just kind of works better working from left to right. So the goal in this question is to take, again, one side of the equation and make it look like the other. Your work is the problem. It's not saying, oh, cosecant theta times tangent theta equals secant theta. That's already given that that's true. It's like a geometry proof. I know what's given. I know what the proof is. What I'm trying to get at the end, I need to show the work in between. So you guys can't cheap out and not show work on these kinds of questions. So I'm going to rewrite the left side of this equation, cosecant theta times tangent of theta, and see if there's anything I can do with my goal in mind of trying to get this to become secant of theta. So just trying to maybe combine cosecant, tangent, thinking that maybe they have some things in common. I know cosecant is 1 over sine, so let me see if that helps by rewriting it that way. And I know tangent, using the quotient identities, is sine over cosine. Now, you may do a step like this and then hit a dead end. Then you would need to try a different approach, a different identity or a different simplification. But because looking at this now, I see that I do have these signs that I can now simplify or cross out. I multiply across my numerator, I get 1. My denominator, I get cosine. So I probably feel like, okay, that's as far as I can go, but what did I really want as my final answer? Well, I wanted to get to secant of theta. Is 1 over cosine the same as secant of theta? Well, if you double check your reciprocal identities, you'll see that it is in fact true. So I get secant of theta. Box it, circle it, happy face, check mark, something to just kind of show that yes, I did get the result that I was looking for. So it'd be like, this is my given, this is my proof, these are all my steps in between. And you want to make sure that those are there. All right, so that was a pretty simple one. Let's go ahead and try another one. Letter B. This one's going to take a little bit more time, a little bit more work. Again, my goal is to take one side and make it look like the other. I notice here that the left side does look more complicated than the right, so I'm going to start with that. This looks a little weird with the negative theta inside and the sine squared. This is something we haven't worked a lot with, but I just want to show you how the notation really plays out. If it's sine of negative theta squared, you could also write it like this. So it's just a notation thing. Normally you put the squared right next to the n or the s here, but it really means that whole value is squared. So I'm going to work on that and chip away at that, but also at the same time look at my denominator. We've talked quite a bit about even and odd properties. So when I see things like negative angles, I'm going to try and simplify that. So sine of negative theta, being that sine is odd, can be rewritten as negative sine of theta. Cosine being even can be rewritten as just cosine of theta. So in my numerator, I'm going to use the even and odd properties also to simplify some more. This would be negative sine of theta, all squared, using the property of sine being odd. And this would then just be cosine of theta, all squared. Well, if you think about, let me rewrite the denominator so we don't lose it or forget about it. If I square something that's negative, it really just ends up being positive. So I can rewrite this now as sine squared theta minus cosine squared theta. And again, it's just a notation choice, but normally we put the squared on the inside. The only reason I rewrote it this way was to try to show you how we could simplify and work with the negative, that it would be equivalent to the sine squared of just the positive angle. And then I'm maybe just going to plan ahead here, knowing that I have a negative and a negative. Maybe if I factor out a negative, I would have two positives plus. And we'll see if that helps a little bit, because I just feel like it looks better. This, using our properties, would just be 1 if you want to use the, well, almost, sorry. It wouldn't be because of the subtraction, but I feel like a lot of you would go ahead and look at your Pythagorean identities and feel like that's just 1. So be careful, because when we see the squareds, we kind of automatically want to put a 1 there. But it is minus. So what I want to do here instead is, remember one of our techniques in example 1 was to use factoring. So I'm going to go ahead and recognize that that's a difference of 2 squares. And rewrite this as sine theta plus cosine theta times sine theta minus cosine theta all over negative sine theta plus cosine theta. Do you see here now we have a factor in the numerator and denominator that actually match? So now I have sine theta minus cosine theta all over a negative 1. Well, remind yourself what our end goal is. We're trying to prove that this actually equals cosine minus sine. Notice we're not exactly there yet, but if I did take this negative and divide it into each one of these pieces, I would get negative sine theta plus cosine theta. And if you needed to, rearrange it, cosine minus sine. And that's what we wanted. So really, these problems can go in circles and circles and circles if you don't try to go for what you really want at the end. So always keep in mind what you're trying to get to. All right, so that's example 2, letter B. Let's try another one. We have 2 more. And I don't have any more line paper right here. I'm going to go ahead and just use graph paper. Letter C, 1 plus tangent of u over 1 minus cotangent of u equals tangent of u. So again, left side looks more difficult than the right side. So I'd probably approach adjusting the left side. So let me just rewrite it on my paper. 1 plus tangent of u over 1 plus cotangent of u. And I understand you guys would look at that and really maybe have no clue how to approach it to actually make this just become tangent. So one option would be doing something like leaving the numerator alone and just remembering that cotangent can be written as 1 over tangent. So at least we're kind of heading in, well, I only have tangents now at least, and I know that that's what I want in my answer. I can't just multiply by a reciprocal right now. I would need to get my denominator to just be 1 fraction. So what I'm going to do is leave my numerator alone and rewrite my denominator as tangent of u over tangent of u plus 1 over tangent of u. The purpose of this is to get a common denominator. Please notice that 1 really would be the same thing as tangent over tangent. So now I have 1 plus tangent of u, that's still my numerator, over tangent u plus 1 all over tangent u. So I don't know if you guys can see it. We're heading in a good direction because I'm seeing 1 plus tangent u, 1 plus tangent u, and those are kind of the same. So maybe we can get something to simplify or cross out here. So whenever I'm dividing by a fraction, I change it to multiply by the reciprocal. Please notice that these 2 pieces in parentheses are equal, even though the 1 and the tangent are just in different order. So I'm going to go ahead and reduce those, and notice that I am left with just tangent of u. Look back at our original question. That's what we wanted to get. So again, I cannot stress enough, I totally understand that you guys aren't going to be, because you don't have a lot of experience with these questions, able to just decide, oh, I'm going to rewrite cotangent as 1 over tangent. How in the world do I come up with that as an idea? Well, it's a lot of practice. So over the next couple of days as you work on these assignments, you need to work together so that maybe one person will have an idea that the other one doesn't. And you just need to try. You need to try different possibilities. Try to stay out of the back of the book. The back of the book will give you steps and show you how you get from one to the other. And it'd be very easy for you guys to just look at that and agree. But you need to be able to come up with some of these approaches on your own. So, last example, or part of example 2, part D. When I look at this problem, I don't really feel like one looks more complicated than the other. So it really would just depend on which side you want to start from. But like I said, I usually like to start on the left and make it look like the right. And then also, guys, just so you know, all of these examples do come from the book. So you can see the work for them there also. And they kind of make some little notes as they go through the steps if you want to go back and look at those as well. So taking a look at this, I just kind of need everything to switch. If you look from left to right, I need the cosine to go to the numerator. I need a 1, but then it needs to be a plus to go into the denominator. So how do I maybe get this kind of switch? Well, one option is to multiply your numerator and denominator by the same thing. Now you can always pick whatever you want, but I would multiply by what I want my denominator to be. So I want my denominator to become a 1 plus sign. So I'm going to go ahead and multiply numerator and denominator by that. And the reason we're allowed to do this is because really that's just a 1. It's not changing the whole question. I'm going to put some extra parentheses in just to make sure it's clear what's happening. If I multiply across the top, I hope you guys can see that this looks like the factored version of a difference of two squares. So you could do distributive property, but hopefully you guys understand it would just be the same thing as 1 minus sine squared theta, or 1 squared minus sine squared, but 1 squared is just 1. Then my denominator is cosine theta times 1 plus sine theta. So again, you're probably thinking, how would I have any idea to do that? Well, you probably wouldn't. That's why we're doing notes, to give you some potential ideas of steps that you would take to get the problem started. So you're just trying out different things. What I'm hoping you would notice is this 1 minus sine squared. We saw that in one of our earlier pieces, how that's just a manipulated version of the Pythagorean identity. And that in fact equals cosine squared. And then I hope you guys can see here that I have two factors of cosine, or a cosine squared, in the numerator, and one factor of cosine in the denominator. So I can reduce one of those, and I end up with cosine of theta over 1 plus sine theta. And again, looking back at the original question, that's what I wanted. So that's really it for the notes, but I just want to say again, I understand that these are difficult questions. I don't feel like it would be any easier if I was right in front of you going over these with you, because I can't hold your hand and walk you through each question every time. You really have to look at the problem. What can I manipulate or change? What identity, what substitution can I do to try to manipulate one side of this equation to match the other? And really, it's just a trial and error attempt some of these different techniques. So I wish you the best of luck. I know that these are difficult questions. Please work together, help each other out, and try not to just spend all your time in the back of the book. So good luck, and go ahead and give it a try.